So last time, what we did is we learned how to solve a system by graphing. And from the looks of the quizzes, you guys kind of got the hang of that, right? Like basically you just graph the two lines, find where they intersect, and that's the solution. So what we did is we learned how to solve a system by graphing. So just to kind of recap the overall strategy here, you'd have two equations like y equals 2x plus 1. That one has a y-intercept of 1 and a slope of 2. And you'd go and you'd graph that, just like I'm doing here. And then you'd have a second equation. In this case, 2x plus 2y equals 8. You might solve that for y to graph it, or you might choose to graph it based on the x and y intercepts, which in this case would be 4 and 4. Connect the dots. Then once you have the two lines graphed, the solution to that system is the coordinate, or the ordered pair, where they intersect, which in this case would be 1, 3. So there's no algebra involved here unless you have an equation that's not solved for y or not in standard form. Then you might have to do a little bit of algebra to get it in there. But today I'm going to show you how to solve something like this with no graph. So this is a method of solving called substitution. And basically what you're going to do is you're going to take your two equations and start just like plugging them into each other and solving for x like we did in the very first unit. So I'm going to guide you through these steps. It's not going to be like a one-step or two-step. It's going to be a multi-step problem. So if at any point I'm going too fast or you don't understand why I'm doing something, like please stop me. All right. So we've got this system of equations, right? The same system that we had up here. We already know what the solution is going to be. It's going to be 1, 3. But I want to show you how to get there algebraically. Now this method is called substitution because essentially what you do is you're going to pick one of the equations, solve for a variable, or in other words, isolate a variable in that equation, and then take that and substitute that expression into the second equation. Now that's step one, solve one of the equations for either x or y. A lot of the time that's already going to be taken care of for you. Like in this system, the first equation is already solved for y. Y is already by itself, right? Y equals 2x plus 1. So if both of your equations are in standard form, you'll have to do that up front. But in this case, we've already got an equation that's set up, ready to go. So step one is sort of done, ready for you. So step two is going to be to take whatever that variable equals, which is 2x plus 1, and substitute, and this is why this method's called substitution. We're going to substitute that expression into the other equation, right? So 2x plus 1 equals y in this problem. So that means that we can basically substitute y for 2x plus 1. If those two things are equal, that means they're the same, right? So in the second equation, we are going to substitute y for 2x plus 1. You might be wondering, like, why would you do that? Well, if I substitute 2x plus 1 for y, that gives me 2x plus 2 times 2x plus 1 equals 8. Basically, wherever that y was, right here, I'm changing that expression to be equal to what y is in the first equation. Now the reason to do that is because now I've got just a single equation with a single variable. You can't solve an equation with two variables. I mean, you can like isolate one of the variables, but you're not going to be able to get a solution for that. But now I have just one equation with one variable. So I'm set up at a point where I can solve for x here. I can get the x part of the coordinate. Now once I get x, I'm going to use that x and go back and substitute it back into one of the first equations to get y. And that'll be sort of like the last thing we do. But once you make that first substitution, then we just start solving like you would solve any old equation. I know it's been a while since we did some solving, so I'll kind of help you guide you through it. You want to start by using the distributive property, if that applies. You don't always need to do that, but if you at any point have like some number times an expression in parentheses, you need to distribute that number that's right on the outside. So in this case, we're going to multiply 2 by 2x plus 1. So everything else should stay the same, but 2 times 2x is 4x, 2 times 1 is 2, equals 8. What should be my next step? We've solved equations like this in the past. What do you think we do next? Combine like terms. Good. So my like terms in this problem are 2x plus 4x, which would be what? 6x. And now we've gotten this down to a two-step linear equation. This should be like the easy. We've already sort of conquered the hard part of this problem, quite honestly. And that's just kind of knowing what to do. At this point, we're going to subtract 2 from both sides. And that gives me 6x equals 6. And what's my last step to get x? Divide by 6, and I get x equals 1. Right? And that is what I'm expecting, right? I know my solution already because we solved this one by graphing at the beginning. I know that x should be 1, but I'm not done yet because I haven't gotten y yet. So part of this whole solving by substitution or solving by graphing is that there's two parts to the answer. There's the x coordinate and the y coordinate. And so what we have right here is just the x. Do you have any idea how we might be able to get y? The what? You know, we could take this x and substitute it. Again, this is why we're calling it substitution. We're making like these really just two different substitutions here. And essentially plug this number into one of the original equations. Now you could plug it into either one and solve for y and get the right answer. But one of the equations is usually going to be easier. And that equation is going to be the one that's already solved for y. Because then you don't have to move things around. You just simplify whatever your expression is. So I'm going to take this x equals 1 and substitute it back in this first equation. Right? Where instead of writing x, I'm going to write 1. So I've got y equals 2 times, instead of x, I'm going to write 1 plus 1. Right? Well, what's 2 times 1 plus 1? 3. Again, this is what we were expecting, right? We already knew what the answer was going to be. But this is how you get the solution without graphing. This method is called substitution. Later in the week, we'll go over the third and final method called elimination, which is kind of similar to this. It's just like a different way of organizing the work. But for now, we've got our solution. I want to write it as a coordinate. Whenever you write the solution to a system, you write it as a coordinate. So x is 1, y is 3, so my solution is 1, 3. Practice makes perfect, right? I mean, the more problems we can do like this, the better you're going to get. I know we only have so much time in class. We'll try to get through all 3 of these. All right, so number 1. Are either of the 2 questions solved for a variable? Like, in other words, is there a variable that has been isolated already? Yeah, the y in the second equation, right? That's kind of what you're looking for as far as like where to start. You know, like in number 2, you can see that the x is isolated, so you're going to start with that. In number 3, y is actually isolated in both, so you have a little bit of wiggle room as far as like which one you want to go with. All right, so let's take a look at number 1. Y has been isolated. So what I'm going to do is I'm going to substitute x minus 3 into y in the other equation. And basically, I'm just going to rewrite a single equation with a single variable. So that equation is going to be 2x minus 5 times x minus 3 equals 9. Right? So I substituted x minus 3 in for y. And once you make that first substitution, you start going on your solving process. All right, and this process will pretty much be the same thing for every single problem. There might be like some slight variations depending on how the equations are set up. But for the most part, you'll distribute, you'll combine like terms, you add or subtract your constant, multiply or divide your coefficient. So here, just be careful because we've got minus 5 times. So when you just distribute, you want to distribute that negative along with it. You get 2x minus 5x, and then negative 5 times negative 3 would be plus 15 equals 9. We do have some like terms here, so we're going to combine those. 2x minus 5x is negative 3x. Now we've got a two-step equation, so we can solve that. Minus 15 on either side. Oh, this one's kind of tricky. What's 9 minus 15? Negative 6. Okay, so we've got negative 3x equals negative 6. So what is x going to be? 2. So that's half of our answer, right? It's not the whole answer. Oftentimes, I see Algebra 1 students like kind of getting x like that and then just, oh, I'm done. I got x. But you got to remember that you also have to get y. This is a coordinate that we're trying to find, a point on the grid. So now we need to get the y, but the second variable in this method is always easier than the first, right? Because you're already going to have an equation that's set up equal to get the variable you want. In this case, y equals x minus 3. And we already know what x is, so you just plug it into that equation. All right, we're going to take this x and stick it right there. So I've got y equals 2 minus 3, and that's really all you need to do. All right, well, 2 minus 3 is negative 1. So now I've got my y. And I can write my solution. 2 comma negative 1. All right, let's try another one. So number 2, notice that the x has been isolated in one of the equations, right? So what we're going to do is substitute this 2y plus 4 expression into x, because that's what x equals. So if I substitute that into x, I get an equation that says 3 times 2y plus 4 minus 8y equals 16. Make a little line here to... So this was the expression that got substituted in. Just instead of writing x, I wrote this. I'm going to distribute the 3, which gives me 6y plus 12 minus 8y equals 16. And hopefully what you're starting to see is that, yeah, we're kind of doing the same steps on each of these problems, right? You do the substitution step, distribution, combine like terms, etc., etc. For the combining like terms step, I've got 6y minus 8y, which is negative 2y. Now I've got to subtract 12. That gives me negative 2y equals 4. So for this problem, what is the y coordinate going to be? Negative 2, yeah. So we got the y first here, and it doesn't really matter like which coordinate you get first, whether it's x or y. That doesn't really make a difference. Just make sure you're keeping track of that. When you write your final answer, your solution, you're always going to write it x comma y, but which one you sort of identify first is not important. So I've got my y. I'm going to take that and plug it back into this top equation. So I have x equals 2 times negative 2 plus 4. So negative 4 plus 4 is going to be what? 0. So now I've got my x. I've got my y. I'm ready to write my solution, which is 0 comma negative 2. And don't lose track of like what that actually means, right? What this means is that if I were to graph these two lines, this would be the point where they intersect. I mean, that's really the bottom line here. Now, if both of your equations have a variable isolated, especially if they're the same variable, these work out kind of nicely because your substitution is just a matter of setting these two expressions equal to each other. Like, if this equals y and this equals y, then they both should equal each other. It's the same concept, it just kind of looks a little different for some reason. I'm going to substitute this 4x minus 12 into y, the other equation, and that gives me 4x minus 12 equals 3 times 2x plus 5. And now I'm just ready to go and start solving. Really, the big difference here is just in the steps. You've got variables on both sides, which we didn't have in the other one. The order of the steps is pretty much the same, though. I'm going to distribute the 3, and that gives me 4x minus 12 equals 6x plus 15. Now when I combine like terms, though, since they're on different sides, I need to move one over. So I'm going to subtract 6x from both sides. A little different from the last one. So that's negative 2x minus 12 equals 15. Now I'm sort of back on track here with the two-step equation. I'm going to add 12 to both sides. Get negative 2x equals 27. Is that right? Uh-oh, is this going to be a fraction? Yikes. No. Oh, oh well. Divide both sides by negative 2.
Negative 13.5.
Okay. Negative 13.5. I guess that's right. Okay. Now, which equation do you think would be easier to plug this into, the first one or the second one? The first one has like less stuff going on, right? There's fewer numbers to keep track of. You don't have to worry about distributive property or anything. So yeah, when you have a choice, always try to go for the simpler one, whichever one's going to be easier to deal with. So I get y equals 4 times negative 13.5 minus 12. This looks like this is, something you would want to throw in the calculator. Yes, sir. Sure. So 4 times negative 13.5 minus 12. I'm not sure what that is. Negative 66? Sounds like that could be right. So you can imagine one of the problems with solving by graphing is like if I try to graph these two lines, look at where the intersection is. Negative 13.5 comma negative 66. That's probably going to be way off the grid. Probably. So one of the advantages to this method is you do not have to worry about like the constraints of your graph or worrying about like estimating decimals or anything. Like this will just be your answer, right? You don't have to worry about trying to identify that intersection. Yes, ma'am.
Oh, never mind. I see that.
So my solution is going to be negative 13.5 comma negative 66. Let's try these last two word problems. We'll be done. All right. So setting up word problems can be kind of tricky. Oh, bless you. My goodness. So it says the perimeter of a rectangle is 38. So this is not like a formula you need to memorize, but I would hope that you know how to. Do y'all know how to find the perimeter of a rectangle? Yeah, you add up all the sides, right? So typically what you say is like it's 2x plus 2y, and since the perimeter here is 38, it equals 38. The length, you know what? Instead of x and y, maybe I need to write these as like length and width. So I'm going to change this to L and W. All right, there's two lengths, two widths. You add them all up, you get 38. The length of a rectangle is 4 centimeters more than twice the width. So the length is 4 more than twice the width. What are the dimensions of the rectangle? Well, we've got two equations, so we've got a system here. We're trying to solve it without a graph, so we're going to use substitution here. This is my system. So L, or the length, is 4 more than twice the width. So I'm going to take that expression and substitute it back into the first one, since that's what L equals. So I've got 2 times 4 plus 2w plus 2w equals 38. All right, I just took this expression, substitute it right here, and that's where this is coming from. So now I just go through that solving process again. Distribute, combine like terms, add, subtract, multiply, divide. I'll get 8 plus 4w plus 2w equals 38. (4w plus 2w is 6w. I need to subtract 8 from both sides. So I have now 6w equals 30. So what's the width? Yeah, the width is 5 centimeters. So that's half of my answer, but I still need to know the length. Luckily, we have an equation for the length. Yes, ma'am.
I know what you can do, I think.
All right, tell me what to do.
So you take the first equation, the 2L plus 2W equals 38, and you substitute the W for 5.
Yeah, so
Divided by 2.
so that will definitely 100% work. But if you substitute it into the second equation, you don't have to move any stuff around. Like if I put 5 right here, then I just have to do 4 plus 2 times 5.
Oh.
So now, you know, you're not wrong, right? Like that works, but do you see how substituting it into other equation will be a little faster? Yeah. So you want to be thinking about that. Do y'all see what like y'all understand what just happened there? Like her suggestion and like why that won't be the most efficient way to do it? So if I plug that in the second one, 4 plus 2 times 5, I get 4 plus 10, which is 14. So the length is 14 centimeters.